Hello everyone, welcome back to PMAC1140. In this video, I'm gonna show you how to solve exponential equation. Exponential equation is equation that contain variable in the exponent, and we have several methods of solving exponential equation. Okay, so let's get started. Okay. Exponential equation. The first method of solving exponential equation it is to use equivalence property. Okay, so method number one. Use equivalence property. What is equivalence property? If I have x and y as a real number, okay, and I raise x with the base b to the x, and if I raise y to the same base b to the y, okay, then this one will imply x equal y. Okay, so this is called equivalence property. So literally this is what it means if you have two exponential expression, okay, and they have the same base. It means we can set up the exponent equal each other. Okay, for example, let's start with our first example here. Example number one. So what if I have 2 raised to 4x minus 5 equal to 2 raised to x plus 1? So I have a expression here, exponential expression. I have another exponential expression. Okay. Now the base is the same. Then I can set up the exponent. If I apply equivalence property, I can set up the exponent equal each other. See that if after I set up the exponent equal each other, you see that it become a very basic linear equation. Now I can solve for x. Then x equal 2. Okay, subtract both sides by x, add both sides by 5. Okay, so as long as you have the same base, you can set up exponent. Okay, if it is different base, then we gotta do some way somehow. You gotta do some way somehow so that it has the same base. Okay, or if it has three exponential expression, then you gotta bring it back to 2 only, because the equivalent property, you see that we have only 2 base. If we have another base, then we gotta bring it to 2. You gotta combine it. Okay, for example, I have base 3 raised to 4x plus 1, and over here also base 3 raised to the x, but you multiply by base 3, okay, x plus 4. Okay, so if you have 3 base like this, you cannot apply the equivalence property right away. You have to combine them. Okay, you have to combine them. So this is the left one is good already. Now I had to combine this. I don't know if you guys still remember. You have the same way multiply each other. Then we gotta add the exponent. So give you 3x plus x, 2x plus 4. Okay, that is one of the exponential formula we already learned. The first time you learn how to simplify exponential expression, remember we have x to the n times x to the m is x to the n times n plus m. Remember this one? Okay, so I applied this formula over here. Okay, apply this formula here. And when I apply this formula here, you see that I can combine these two bases over here to one base only. And now the base are the same. I can set up the exponent equal each other. Okay, give you 2x, 3, x equals 3 over 2. Okay. Now, what if the base is not the same? Then we got, of course, then we gotta do some way somehow so that it become the same, right? For example, in this problem here, I have something like this. I have 3 raised to 2x minus 6, and over here I have 81. Alright, on the left hand side is base 3 and it's a prime number already. On the right hand side is base 81, the exponent is 1. It's invisible 1 here, so that you see the base is not the same. So, because on the left hand side is the base is a prime number, we cannot convert anything else. On the right hand side, I can rewrite this. 81 is actually 9 times 9, which is 3 raised to the 4. So you see that I do one more step so that the base is the same. As long as the base is the same, I can set up exponent 2x minus 6 equal 4, then 2x equal 10, and x equal 5 as the final answer. Okay, as the final. And remember that no matter what type of equation, okay, you're doing, you know what? You have to go back and check. Okay, you got to go back and check. It means that you have to plug it back into the original equation to check if it is satisfied or not. Okay, I've just drawn a square over here so that you guys know that this is the end of the problem. There you go. Okay, I don't have to box it. Usually I box it, but when I box it, the box is not beautiful, so I'm gonna make a small square right here. Okay. All right. Example 5. Oops. So you gotta change. You gotta manipulate some way somehow so that the base is the same. Okay. And you have to try that. You gotta try to manipulate as much as you can so that the base is the same. I can give you another example. Okay. What if I have this? I have okay, I have 100 raised to 3t minus 5 equal 1000 raised to 3 minus t. Alright, in example number 4, I just need to convert 81. Now I gotta bring it to the same base, and I know the 100 is 10 square raised to 3t minus 5, and 1000 is 10 to the third raised to 3 minus t. Now if I go ahead and apply the formula x to the n raised to the m, okay, let me use this color, x to the m raised to the m, is that equal to x to the m times n? We already learned this formula, so I'm gonna go ahead and multiply this. So this is give you 10 raised to the 2 times 3t minus 5. I give you 10 raised to the 3 times 3 minus t. There you go. Now the base is the same. Then I can set up exponent equal each other. Alright, and now we're gonna solve for x. So I distribute it. 6t minus 10 equal 9 minus 3t. Alright, so which is 9t equal 19. Alright. So t equal 19 over 9. Here you go. Done. Okay. Okay. So you have to follow the rule. Okay. Try to apply all the exponential formula and try to apply the equivalence property. Try to convert it to the same base, even though at the beginning it's not the same. Try to recognize it. What base you change to. Okay. You have to. Otherwise, you cannot do it. Alright. How about this one? Example 6. I have 25 raised to 4 minus t, and it is equal to 1 over 25. 1 over 5. Sorry. 1 over 5 raised to 3t plus 1. Okay, so let's change this to 25. 25 is 5 square, right? And this is 1 over 5. Remember, 1 over 5, and when I flip them up, it becomes 5 raised to the negative 1, raised to 3t plus 1. Okay, so remember that. Remember that formula. Let me write that formula here. If you have 1 over x, okay, then this is become x to the negative 1. Remember this formula? Okay. Because 1 over x is, x is x to the 1. If you flip them up, it becomes negative 1. Okay. Okay, now the base. Now I'm going to apply this formula here. So I have 5 2 4 minus t equal 5 minus 1 times 3t plus 1. Now the base is same, right? And I have exponent equal each other. Okay, exponent equal each other, so we give you 8 2t negative 3t negative 1. So you have t equal to negative 9. Alright. Again, you gotta check, okay? Because when I'm doing it, I don't have to check. I should, but I mean, I don't need to waste too much time on checking. But when you do homework, you gotta check. You gotta plug over here and check. Okay, you have calculator. You can plug into calculator and check. Because sometimes this value is not a solution, and if you do homework and you put this in your as a solution, then of course it will be wrong, right? In this case, if you plug it in and this does not satisfy or both sides not equal to each other, then you have to jump to the conclusion there's no solution. Okay, so you have to be careful. You gotta check all the time, no matter what type of equation you do, and you gotta check all the time. Okay, let me draw this square here. Good. All right. Okay. Of course, some problem. No matter how much you try, you cannot convert it to the same base. If you in that situation, okay, then you have to use the second method, which is the method number 2. Method 2. Okay. So what is method 2? Method 2. Okay. This is the first Roman. Method 2 is we're gonna take log both sides. Okay, we're gonna take log both sides. Okay, I think we're gonna put over here take log both sides. Let's rewrite it. Take log both sides. But what type of log? What type of log? You can do any log you want, to be honest. It depends on the problem. If the base is base E, you can take natural log. If the base is base 10, you take log base 10, you know. If the base is base 3, you can do base 3, or you can also do base 10. It's up to you. Okay. You can do any base you want. Depends on the problem. Okay. For example, I can give you some problem like this. I have a problem like this. What if I have let's see, I can do okay, how about this example number 1? I have 4 2x minus 7 equal 5 3x plus 1. Okay, so if you notice, you see that over here I can change to base 2, but 5 is a prime number. I cannot change to base 2. There's no way we're gonna change to the same base. No matter where, no matter which side you want to start, you cannot change to the same base. So in this case, you have to take log both sides. Okay, and you can take log base 5. You can take log base 4. You can take log base 10 if you want. Most of the time, people take natural log. So over here, I'm gonna take natural log for you. So I'm gonna take natural log both sides. Okay. Okay. So I take natural log here. There you go. I don't have to put there. And when I take natural log both sides, we're gonna use one of the log property we already learned. I don't know if you remember. This is the log property we already learned. Log base b of x to the n and equal to n log base b of x. So we're gonna use this. And if I use this, you will see that I can drop down the exponent, which is the exponent will be 2x minus 7 times log base e of 4 equal to 3x plus 1, which is the exponent on the right, times log base e of 5. Now our job is to solve for x. So in order to solve for, we need to isolate the x. So you have x here and x here. We need to isolate the term with x. But in order to isolate, you got to distribute them. Okay. 7 ln4 3x ln5 plus ln5. Now you see that there are two terms with x, so we're gonna move them together. Subtract 3x ln5, and the other one without x, you're gonna move to one side, so you have 7 ln4 plus ln5. Now we want to solve for x, right? I want to solve for x here, so I have to factor the x out, right? Because remember, when we solve any equation for x, right, we need to isolate it, and on the left hand side there's only one x left. You see, you have one x here, it's not good. We need to bring it to 1x by factor them out. Okay. And now you can solve for x by divide both sides by the whole piece of parentheses right here. There you go. That will be your final answer. Yeah, the final answer seems to be complicated, but that's what it is. You can put into the calculator to calculate amount as a decimal number, or you can leave it like this. Okay, you can leave it like that if you want to. On the test, I think you can leave it like this. Okay, good. Okay. And you can take log space 4 if you want to. You know, you can take any log. Depends on the problem. All right. Example 2. Now, what if I have this? What if I have 10 raised to 5 plus 2x plus 820 equal 49,600. Okay. Alright, so we're gonna solve for x here. So first of all, we're gonna go ahead and subtract both sides by 820, so you give you 48,780. Now you see that there's no way we can change this to base 10. No way. Alright. What number multiply each other with base 10 to get this? No way. Right? No way. Okay. So you gotta, over here is 10, so I'm gonna take log base 10. See, I don't do natural log anymore. And now I drop it down because log base 10 of 10 is 1, and log base 10 of this big number is whatever it is. Now I'm gonna solve for x by divide both sides by 5. Then you subtract both sides by 5 first, then you divide by 2. There you go. Okay. Then you got the answer. Okay. Now let's do another example before we switch to the last method. Example number 3. Okay. Now what if I have this? I have e raised to the x squared, okay, equal 200. Okay. So we have base e over here, and no way we can change 200 to base e. So I'm gonna take natural log both sides. So I'm gonna do ln equal ln 200. So the exponent over here is x squared. Can drop it down. ln of e equal 1. So I have x squared equal to ln 200. Then from here, we will have x equal plus minus square root of ln 200. Okay. And that's it. You can go ahead, calculate the amount into decimal number if you want it, or you can leave it like this. Okay. Okay, how about this one here? You have to be exposed to different form of exponential equation, believe me, because this is a general method. However, each problem we approach is different, so it depends on each problem. For example, in this one, you see that I have something like this, number e negative 4x and this is equal to 3e. First, we can combine these two because they're the same base. So I have base e of 2x plus 1 minus 4x equal 3e. Now I'm going to combine this again and combine this, which just give you e raised to the negative 2x plus 1 equal 3e. Alright, so the problem over here, we have number 3, even though the base is the same, but we cannot set the exponent equal to each other. Because according to the equivalence property, in front of the base we don't have any. So we cannot use the equivalence property now. However, just think about it. If I go ahead and divide both sides, okay, I divide both sides by e. Alright, so over here I can cancel the e, so what I have left is just 3. And when I divide this like this, remember the one of the formula, if I have x to the m over x to the n, that is equal to x to the m minus n. Then this one here, I can write this as e raised to the negative 2x plus 1 minus 1 equal 3, which is equal to e to the negative 2x equal 3. Now, in order to get x, you're going to take natural log both sides. Okay, ln 3. And it becomes negative 2x equal to ln 3. And over here I have x equal to negative ln 3 divided by 2. So that will be your final answer. Okay, that will be your final answer. So you gotta do flex. You gotta be flexible. You know, you gotta be able to recognize that when you divide both sides by e right here, you can apply this formula. So I mean, that's why I say that whatever you learn in intermediate algebra, exponential simplification formula, you have to memorize it. This formula and the other, this one, and this one. And this one, and the one you just learned recently, you have to memorize it so that when you memorize it, and you can see right away. Okay. All right. The last method. Okay, the last method. Method 3. What is method number 3? For method number 3, we can factor them. We can factor them. Factoring. And because we can factor, so we can use zero product property. You know, split them up and solve one by one. For example, I have this. Example 1. What if I have e to the 2x minus 4e to the x plus 3 equals 0? If you recognize that this is e to the x, I can rewrite this as e to the x squared, and this is minus 4e to the x plus 3. This is nothing but a quadratic. Something square, right? A quadratic. So I can factor this. So it will be e to the x and e to the x here. And you end up with this negative 4. So it must be negative 3 and negative 1. There you go. So you recognize the quadratic, okay? That's what you do. Now we can apply this zero product property. And from here I have e to the x equal 3, e to the x equal 1. You take ln both sides. You take ln both sides. ln of 1 give you what? 0. Right? You take ln both sides here. ln of 3 is just ln of 3. So you have two answers. X equal to 0 and x equal ln of 3, which it makes sense because it's in quadratic form. In quadratic we have two solutions, right? Two answers. Okay. So factoring, you have to recognize the quadratic. Okay, that's what you do. If you cannot recognize the quadratic, then you cannot factor. Of course, you can sometimes you can factor by GCF. For example, I have what if I have this? I have 4 raised to the x times e to the x. Okay. Minus. Okay, minus minus e to the 2x equals 0. Alright. If you notice, I can write this e to the 2x as e to the x squared, right? Now what is in common? E to the x in common, right? So if I go ahead and find GCF here, you have 4 to the x left inside minus e to the x, right? Equal to 0. There you go. You see that? Now it's in product form. I can go ahead and split the e to the x equal to 0, or 4 to the x minus e to the x equal to 0. E to the x equal to 0. There's no solution here. No solution. Why? Because remember, for any e to the x function, the function is go like that, right? The function is go like that, and there's no equal 0 here. It's everything the range is always greater than 0. It never be 0. Okay, so there's no solution here. Okay. For this one, you see that if I go ahead flip this one over here, you see the base is no way we can convert it to the same base. So you're gonna take natural log both sides. ln for x, ln e x, and you drop it down to the front according to one of the log property, x ln 4 equal x, because ln e of e give you 1. Now we're gonna solve for e, so we're gonna go ahead and subtract both sides by x, because in order to solve for x, you bring everything out and you factor the x out, so you have ln 4 minus 1 equal 0. Then x equal to 0 divided by ln 4 minus 1, which is x equals 0 as the final answer. There you go. And you can check it. Use x is equal to 0, 0 give you 1, 0 is 1, 1, 1, 1 time minus 1, x to the 0, 0, e to the 0, 0, e to the 0, 1, 1 minus 1, 0. Alright, so the final answer is this. So for factoring, you can find GCF, or you recognize the quadratic equation form. Okay. Let me see. I have something else. How about this one right here? Example number 3. What if I have 5 to the 2x plus 3 5 to the x equal 28. Alright, so in order to recognize it, you see this is square right here and 5 to the x, so I can rewrite this. Okay. And I subtract both sides by 28, and now it has a quadratic form. So I have 5 to the x, 5 to the x, And 28, I have to factor 28, which is what a factor of 28. 28 could be 2 and 14, right? And it could be what else? 7 and 4. All right. And you see that we're going to use 7 and 4 because we need to end up with 3. So we're going to have negative 7 plus 7 and negative 4. Alright, now we go ahead and split them up. Alright, so I have 5 to the x equals 4. Now we're going to take ln. Or you can take log base 5. Okay, I never take log base 5, right? So let's try to take log base 5. Log base 5 is here. So log base 5 of 5 give you 1 according to the property. So you have x equal to log base 5 of 4. That's the final answer. Okay, so one of this answer. And over here, you have 5 to the x equal negative 7. And of course, this is no solution. Because according to the sketch, right? Exponential function is all the range is always greater than 0. It doesn't have the bottom here, they have a negative, so it's not gonna be here, so we don't have any solution. Alright, so we have only one solution over here. Okay. Let's see, anything else, anything interesting? I think I'm gonna stop right over here because I don't want to give you like challenging problem. Every problem over here is very standard, and we don't want to go further than that. Of course, some problem is hard, some problem require you to do more, but I keep it standard. Okay, we don't want to go further than what we're supposed to do in this class. So I think that I'm gonna just stopping over here. Okay, if you have any question related to the method of solving exponential equation, please do not hesitate to send me the message through Canvas. Okay, I'll be seeing you next time. Bye bye.